Today I will be explaining my project about analysis on project delay and effects of software development using statistical and machine learning techniques. So the companies that provide services like websites, apps who develop them, these companies, even after such a perfect planning, they may be lacking behind on delivering their projects on time, and that is the main reason why I am focusing on this project. The main aim of the study is not only to analyze the problem, but also to provide meaningful insights so that they can help improve the decision making of all the higher level authorities in the company. So the objective of my study is mainly to study what are the reasons, what are the factors that actually affects these delays, these defects. Secondly, to classify delayed and non-delayed tasks, and to explore patterns in development process using clustering techniques. So the research methodology is where I have simulated 18,000 different tasks that are inculcated in this SDLC process, where there are 7 different steps such as planning, design, implementation, testing, deployment and maintenance. So first I simulated this data because the data that was provided to me during my internship was very confidential and I could not use this data directly. So I simulated the data, and then I moved forward with descriptive statistics, data visualization, linear regression, ridge regression, loss regression, logistic regression and many more. So first I made sure that I had all the visualization of the data with me. Then moving forward with the correlation, what are the factors that actually affects the delays the most, which makes the what we can say the project be delayed the most. Then moving forward, I went on with the clustering of the data. So I used elbow method, silhouette score, Davis-Baldwin solution, and Kalinski-Arvaz score, making sure that I have optimal solution about what the K for my clustering should be. So from all these 4 methods, I found out that K equals 2, means 2 clusters are the optimal for my study. So for using this cluster validation technique, even after that, I can clearly say that the 2 clusters are the best for me as delayed and non-delayed tasks, or the task which actually affects delay the most. Moving forward, I went on for PC analysis, where PC was applied to reduce the dimensionality, so I can what we can say bifurcate the data better. So only 2 components explain 72.6% of variance. PC1 captures most of the major variation, and PC2 captures the rest of the variation. Now moving forward to the conclusion, from the ANOVA test, hypothesis testing, whatever I have done in my analysis, I found out that development and testing are the ones that actually creates most of the defects and delays that need to be monitored the most, and the clusters where the tasks which are more problematic should be considered and should be rectified. What were the problems over there? That is what I have conclusion over here. About future scope, I have my future scope about this to apply it on real life data, and I'm right now working on an AI chatbot that helps decision makers to work according to SOPs and make sure that all the decisions that I've taken are statistically correct and data driven. Thank you.